Today we're talking about congruent triangles using the side angle side postulate. So our essential question is, how do I prove two triangles are congruent using the SAS postulate? Again, I would remind you that postulate means rule. So to know that, or to prove that two triangles are congruent, you need to know that specific order combination of corresponding parts are congruent. Specific because I'm asking for specific ones, and it has to go in a specific order. So this time we're talking about side angle side. That's where the SAS comes from. And for side angle side, if two sides and the included, that means inside, and the included angle of one triangle are congruent to the same thing on another triangle, then the two triangles are congruent. So when we look at this first example, you can see that this is the included angle. That's what it means, like it's between the two sides I'm talking about. So PQ needs to be marked or specified as congruent to WX. Angle Q needs to be known to be congruent to angle X, and side QS needs to be congruent to XY. If those three pieces of information are proven or shown, then we can state that triangle PQS is congruent to triangle WXY. So to be side angle side, the angle side angle side. Notice that it goes around in kind of a flow. Or it can be side angle side. But each time the angle was in between the two sides that we were given to be congruent. Examples that would not be side angle side would be where the angle is not between the two. So these are not side angle side. The included angle needs to be between the two sides that are given to you as congruent pairs. So let's look at the first example. I have a side and an angle and a side. And I have a side and an angle and a side. And they match. This side and this side. And then this side and this side with the included angle being in between. So these are congruent triangles by side angle side. When I look at number 2, I don't have any sides that have been marked. And just because something has the same angles doesn't make it the same size. So I cannot determine if these are congruent with the information that's provided. when we look at number 3, I can know that this side is congruent. But while this one is side, angle, side, the two angles that are congruent, for this one, it doesn't work. This angle is not between these two sides. So this is not congruent. When we look at number 4, I'm only given 2 pairs of corresponding sides. But because of our previous work, we know that these are vertical angles, and we know that vertical angles are congruent. So then I can say that this is congruent by side, angle, side. And remember that it has to go in that order. So when it says specific order, it means side, angle, side. So now let's look and see what information is missing to be able to identify side, angle, side congruency. I need to know that these two angles are congruent. So I need to know that FRP, angle FRP, is congruent to QPR. That's the first thing I need to know. And then I need to know if RP is congruent to PR. For number 6, it's easier because they don't share a side. So I just need to know that those angles are congruent. I need to know that angle B is congruent to angle E. I need to know for sure that EF and FE are congruent. I can say that with the reflexive property, but I would still have to state it before I could use side, angle, side. Then I need to use this angle because it's between the 1 and the 2 hatch side, and this angle because it's between the 1 and the 2. So that's angle ZFE needs to be congruent to angle DEF before I can use side, angle, side as my postulate. Again, because they share a common side, I can use the reflexive property, but I would need to state that AC is congruent to AC. And then I would need to state that those two angles, angle BAC is congruent to angle FAC before I could use the side, angle, side postulate to prove congruency between those two triangles.